Shalom to you and welcome. In this video, we'll be solving inequalities. So we're going to use interval notation to represent solutions of inequalities and use properties of inequalities, and then solve inequalities and combined inequalities. So inequality symbols, like we already know, is greater than, less than. So if you make your right muscle, it gives you greater than. Think of right, the number goes bigger on the right on the number line, and the number goes less on the number line on the left. So if you use your left hand to make muscle, that gives you less than sign. When you have greater than or equal to, so you combine that with a slash, and less than or equal to. So again, always read from left to right to give the interpretation. An inequality is a mathematical sentence. Sentence is a full sentence. So instead of having an equation, just like equation is a full sentence also, but an equation may have explicit solution, but inequality would have multiple, a range of solutions, range of numbers within the inequality. So again, he uses those symbols to compare numbers. Solution of inequality is any value, any number that will make the inequality true, a true statement when you read it. The notation, when you have like a less than x, which is less than b, it means that x is a value that represents any solution of this inequality. It goes from a to b, but a and b are not solutions, so only numbers in between them are. So this expression is also equivalent. You can also write it, separate them, because there are two expressions here, but x is connecting them. So you can write them separately as a is less than x and x is less than b. So it is joined. They are joined. If you draw the line, if you draw it on the number line, they are going to be connected with each other. So if you see the symbol that looks like greater than or equal to, that means that the number or the expression is equal to the number as well. So if the 53 is greater than or equal to 53, that will be the same thing, because 53 is less than or equal to 53 because it is both equal and greater than. It is both equal and less than. Okay, so you can have 53 in that as part of the solution. So these may be new, okay, but we need to learn them, get familiar with them. So the way we can write solutions of inequality is that in notation, when the like a, b are part of the solutions, we use a bracket, so it is closed. We use bracket. So think of bracket as it has hook in it, so the a, b are hooked in, but parentheses is not hooked. It's just, it's kind of open. It can easily slip away. Okay, so that's the way I think of it. Think of a way to remember it. So when you have just less than, it's open, so a and b are not part of the solution. And if you draw them, okay, it is shaded here. If you put it in parentheses or in bracket or parentheses, open, closed, hooked in. And then sometimes you have one side open and the other side closed. So like here, a is less than and equal to, so a side will be closed. And b is just less, x is less than b, so that one will be open. Again, sometimes they use the dot, open, closed. And then when you write it, know that bracket means closed and parenthesis means open. So infinity is always open, so because it has no end. So yeah, so it can be infinite, finite, open, finite, closed, infinite, open, infinite, closed. Okay, From negative infinity to positive infinity, that is all real numbers. All numbers there is open all the way. So, okay. So keep in mind, simple measure idea, we need to always remember whenever we square any number, both positive and negative, it has to be always positive. So let's say if we square negative 2, it's going to give us 4. If we square 2, it's going to give us 4. So squaring will always make a number positive. That means anything greater than or equal to 0, it can be equal to 0, because if you square 0 squared is 0. So, okay. Okay, sometimes also remember that inequality symbol could be reversed. It could be flipped. So, for example, when you rewrite the expression, here 3 comes first before the inequality sign followed by x. Here x comes first followed by the inequality. So once you change the way you read it or say it, you've also changed the symbol, because it wouldn't make sense to say that 3 is less than x and then you say again that x is less than 3. That would not make sense. So if 3 is less than x, then x must be greater than 3. Okay, so it's just common sense there, but you need to always read it, okay, to interpret it. So another time you've changed the symbol is when you multiply or divide by a negative number. So if you add or subtract negative, it doesn't change it, but when you add or multiply or divide, and when that happens, just look at the expression also. If you pay attention to it, you see that it will not make sense. So you have to change it. So it's always good to read it also. So let's solve problem. Okay, and then we write our answer in interval notation. So this is double. So we're going to do to whatever we do to one side, we do to all the sides. So here our focus is getting x by itself in the middle. So we're going to follow the process of solving equation. Except when we divide or multiply, then we flip the inequality. So here, first of all, we're going to multiply every side by 2. So put this here. So if we multiply by 2, multiply by 2, multiply by 2. So we are multiplying by positive 2, so inequality will not change. So this will give us 2 over 3 is less than x plus 1, which is less than or equal to 2 times 2 is 4 over 3. Okay, so next we're going to subtract 1 from both sides. So if we 2 over 3 minus 1 is less than x, which is less than or equal to 4 over 3 minus 1. So we're going to put those two terms together. We can make 1 to become 3 over 3. So because to subtract or add fractions, we have to have a common denominator. Anything over itself is 1. So we can replace that 3 over 3 with 1. Okay, and then so we can subtract 2 minus 3 is negative 1. So negative 1/3. And it's less than x, which is less than or equal to. Now, have we subtracted or multiplied by negative 1? Have we divided or multiplied by negative 1? Okay, let's finish this and then we check the meaning. So we are subtracting 4 minus 3 is 1, so 1/3. So negative 1/3 is less than x. Negative 1/3 is less than or equal to, and x is less than or equal to 1/3, positive 1/3. Yes, negative 1/3 is less than negative 1 or positive 1/3. So that looks okay. We don't need to flip the inequality. So now we're going to write our answer with a set notation. So we say our solution is the set of x such that we put it in plain, set of x such that negative 1/3 is less than x, which is less than or equal to positive 1/3. So this is one way of expressing it in the set. And then interval notation, we're going to have, since the negative 1/3 is only less, so it's going to be open negative 1/3, comma, and then 1/3 is also equal to, less than or equal to, so it's going to be closed. And then if we draw the line, number line, we don't have to put all the numbers unless we are given the number line already. Otherwise, all you need to do, just remember that 0 is somewhere here and the negative is on the left side of 0. So put negative 1/3, and positive 1/3 is going to be on the other side of 0. So just show that enough, and then we're going to graph the, again, just like the way we did it here. It's open on the 1/3 and it's closed. It's open on the negative 1/3, is closed. Sorry, this has to be on the line. Okay, and then x is anywhere in that space, including 1/3. Okay, that's it. So you need to know all the ways of representing it and then graphing it. Okay, so next we do the same thing. We have less than. So first of all, we're going to subtract 1 from all the sides. So if we subtract 1, the left side will be 0. So we have negative 1/2 x, and less than, subtract 1. So we have 3. And then next we're going to multiply every side by negative 2, which is the reciprocal of negative 1/2. So if we multiply by negative 2, multiply by negative 2, multiply by negative 2. So that will give us negative, anything times 0 is 0 anyway, so less than. So we have x and then less than. Now, since we multiplied by a negative number, so our inequality is going to change. If it doesn't, if we leave it like that, we will see that it will make sense. So divided by a negative number or multiply by a negative number, so inequality will change to greater than, so negative 6. And you see, that makes sense because 0 is greater than negative 6. So it will make sense to say that 0 is less than negative 6. So we're going to rewrite it, since our initial one has less than. So we're going to rewrite it, put negative 6 first. So negative 6 must be less. Since x is greater than negative 6, then negative 6 is less than x. And then 0 is greater than x, so x is less than 0. Okay, so we can say our solution is a set of x such that negative 6 is less than x, which is less than 0. And then so put it in a set notation. Both of them are open, so negative 6, 0. And then if we do our graph, so we have again 0 somewhere, and then we have negative 6 somewhere. If you like, we can put other numbers, but you don't have to. So both of them are open at negative 6 and open at 0, and so solution is in between there. Okay, so here we're giving inequality to us find what the value of a and b are. So if you notice, we're actually giving the solution. Normally we are given an inequality like this, we solve it, and then we get a solution like this where the variable is by itself. So now we are given the solved one, and they want us to go backward to create the inequality, so we know what number will be A and B. Okay, so we look at what happened to x here. So 6 was subtracted from x, so we are going to do the same process. Whatever we do to one, we do to the other until we get that expression. So we are going to subtract 6 from both sides, from everything. So 2 minus 6, it's -4. It's less than x minus 6. Less than 4 minus 6 is -2. Okay, so we look at it again. What happened? We have this bar, so we don't just put it under bar. What can make that happen is when we have the negative exponent. So having a negative exponent is making this whole number, making them fractions, so we make them less. So it will act like dividing by a negative number. So we have -4 to the power -1. So that will flip the inequality. So x minus 6 to the power -1 and -2 to the power -1. And so that will, anything to the power -1, put it under 1. It's -4 is greater than 1 over x minus 6, which is greater than 1 over -2, or -1/2. So what happens now? Yep, it's -1/4 and -1/2. Which one is greater? We see that, yeah, -1/4 is greater, because for negative number, the negative numbers, the bigger they get, the smaller they will get. So, but then since we are originally given the expression is written with less than, so we want to switch it so they become less than. So it's -1/2 is less than 1 over x minus b, which is less than -1/4. So, and if we don't do this, we will make mistake and think and write -1/4 as our A, but the expression has to look exactly like this. So we know that our A is -1/2 and our B is -1/4. Okay. All right, let's do more. Okay, another one. Okay, this one, the same thing, but it looks like just x was multiplied by -4, so we do that. But again, when we multiply or divide by a negative number, the inequality will change. So if we multiply this by -4, multiply by -4, multiply by -4, that will be -4 times 2 is -8. Again, inequality is going to change. -4x. The inequality is going to change. So 3 times that is -12. And again, so we have achieved the goal, but then we have to make it look like this. So we change the equal less than sign. So we're going to write -12 first, less than -4x, which is less than -8. And we can try solving this inequality, see if we get this result. So A equals -12 and B equals -8. Okay. All right, what is the domain of the variable in the expression? Okay, if we remember, anything under the radicand has to be greater than or equal to 0. It cannot be negative. Therefore, if we take 8 plus 2x, set it greater than or equal to 0, and then we solve the inequality to find the value of x. So if subtract 8 from both sides, so 2x is greater than or equal to -8. And then we're going to divide both sides by 2. So since we are dividing by a positive number, the inequality sign does not change. Even though 8 is positive, it's negative, the inequality changes only when the divisor is negative. So we need to remember that. So this is when x is greater than or equal to -4. So this will be the domain. The domain is all the values of x that this function can take. So it can take from -4, -3, -2, anything from there, including fractions that are within that range. So now what is the range? The range is the y values that we go starting from this x value. So we are going to we're going to plug it in. So y has to be greater than or equal to the square root of 8 plus 2, and x, when x, because the range can only come in after you put in the x. Therefore, we have to start, since the domain starts from -4, we have to start our y from that -4. So that will be 8. 8 times 8 is 0. So and square root of 0 is 0. So y has to be greater than or equal to 0. Therefore, this ordered pair x, y is the first point to start the graph, and then it's going to start from here and then go to the right. As x increases, we can find more points and then see which direction it goes. But it doesn't have arrow on both ways. It has to have arrow only on one direction, starting from here. Okay, that's the property of. What is the domain of the variable of this expression? What is the range of it? So you can do the same thing. Again, remember to always pause the video and try it on your own. So we do the same thing for the range. 3x plus 6 has to be greater than or equal to 0. Subtract 6 from both sides. To be greater than or equal to -6. Again, we only subtracted, and we are going to divide by a positive number, so that will not change the inequality sign. So that's -2. Again, to find the range, so this is the domain. To find the range, we are going to, y has to be greater than or equal to the expression we plug in, -2 plus 6. So y has to be greater or equal to, that's -6 plus 6. Turns out to be 0 again. Okay, so that's the range. The range, it doesn't mean that it's just, again, it's equal to 0, but then it's greater than 0 also. So from 0 onward. Okay, that's it. Oh, okay, let's solve this problem. A young adult can be defined as someone older than 21. So let's say age has to be greater than 21. It has to be older. So even if it is 21, it's not yet. It has to be past that 21. And then, so after that birthday, 21, first birthday, then the following day, maybe the person is a little, older. So, or age has to be less than 30. Therefore, so age is in the middle. So age has to be less than 30. And then since age is greater than 21, 21 is less than age. So we put 21 is less than age. And that's what they want us to write. Okay, I promise that should be the last one now. Thank you.